Alright, in this lesson we're looking once again at solving radical equations. The difference here is we're going to look at ones that are just a little bit more complicated. Essentially, we're going to look at ones that have roots on each side, okay? So when we have more than one square root or more than one cube root, what I have to do is I have to isolate each of them individually. So I'm going to isolate one of them and undo it, and then I'll isolate the next one and undo it, and I'll keep doing that until there are no roots left in the equation, and then finish solving for what's left, okay? For example, when I look at this first one, in this example, because I have two radicals, there's no way to have them both isolated, okay? I can isolate one or the other. Right now, the larger of the two radicals is isolated, but if I were to try to isolate that square root of x by subtracting the 1, then the larger radical wouldn't be isolated anymore. So really, I can only isolate one of these at a time. My recommendation here is to isolate the larger radical first, okay? It just gives us a little bit less to deal with as we start to undo these things, and you'll see what I mean in a moment. So with this first one, the larger radical is already isolated, so I'm going to square each side to undo this larger radical. And so what happens is over here I'm left with the 25 minus x. Over here, this is a binomial being squared, which means I have to take the 1 plus root x times 1 plus root x. And so now I've got to multiply this out. I've got to FOIL or distribute here. So over here I still have the 25 minus x. Over here, when I start to do my distributive property, I distribute that 1. That gives me a 1 plus root x. Then I distribute the square root of x. That gives me a plus root x and a plus root x times root x. Remember, that's going to be like a root x squared. And remember, roots and exponents cancel each other out. So here's what I'm left with. I got 25 minus x. Over here I have the 1. Here this is a 1 root x and 1 root x. That's going to be a plus 2 root x. And then a plus x. Alright? Because the square and the square root cancel each other out. So you see what happens here is I still have a radical left in this equation. So now I need to isolate this radical. So the thing that's got the radical right here, that's the thing I have to isolate. Alright? So I'm going to bring everything else over to the other side. So let me subtract the x and the 1. So I'm going to subtract the 1 from each side. And I'm going to go ahead and subtract the x in the same step. Hopefully that's not too much for us. And so what I'm left with, over here I've got a 24 minus 2x. Over here I have a 2 root x. And now from here there's a couple options. Normally we would divide by the 2. You could square each side, but that's just a little bit more difficult. So I'm going to bring this over here. And I'm going to go ahead and divide each side by the 2. Let me divide each side by the 2, and then I'll bring the answer over. So that's going to give me a 12 minus x equals the square root of x. Now I can go ahead and square each side to undo this second radical. Once again, when I do that, this is a binomial, so I have to do the 12 minus x times 12 minus x. And that's going to just equal an x. The root and the exponent cancel each other out. And so now from here, I've just got to multiply this thing out. That's going to give me a 144 minus, that's going to be a 24x plus x squared. And now I'm going to go ahead and subtract the x from each side, get everything over to one side. And I'm doing that because I have an x squared, which means this is a quadratic. And to solve a quadratic, I need it equal to 0. So now I have x squared. That's going to be a minus 25x plus 144 equals 0. And now from here, I either have to solve by factoring, quadratic formula, or completing the square. So I always check factoring first. I build a bridge and ask myself, are there two numbers that multiply to a 144 but add to a negative 25? And so the two numbers I come up with are going to be a negative 16 and a negative 9. And you might have a little bit of trouble coming up with those, and that's okay. It might take a little while. You could always do your quadratic formula or completing the square. So this one's going to factor into an x minus 16 and an x minus 9. And now I set each factor equal to 0. So I do the x minus 16 equals 0. I do the x minus 9 equals 0, and now I solve each. So here I find out that x equals 16, here I find out that x equals 9, but I'm not done yet. I have to plug each of these back in, make sure they work. So when I plug the 16 in, over here, right here I've got 25 minus 16, which is a 9. The square root of that is a 3. Over on the other side, I have 1 plus the square root of 16. Well, the square root of 16 is a 4, so I have 1 plus 4, which is 5, which does not work, so the 16 is no good. So let's try the 9 instead. So if I try the 9 over here, if I plug the 9 in, 25 minus 9 is a 16. The square root of that is 4. Over on the other side, I've got the square root of 9, which is 3, so I have 1 plus 3, which is also 4. So that one checks out, so this one works. So I only have one solution here, and it's the x equals 9. So once again, make sure you plug these back in because you will get extraneous solutions, okay? If I look at the next one, again, the larger of the two radicals is already isolated, so I'm going to go ahead and just undo the larger radical first. So I'm just going to square each side. When I do that over on this first side, I'm going to be left with the x minus 15. On the other side, this thing, I've got to square this binomial, so I do the binomial times itself. I'm not going to write it out this time, but if I multiply that out, that's going to be a 9 minus 6 root x plus the square root of x squared, which is just going to give me an x, okay? And the more you do those, the easier that's going to become. Take it off to the side, multiply it out, and see what you get. And now from here, I have to isolate the radical again, so I'm going to subtract the x and the 9 from this side. And what happens over here is I'm just left with a negative 25, or sorry, a negative 24. Let me try that one more time. Equals a negative x, negative 6 root x. And now I divide by the negative 6. That gives me a positive 4 equals the square root of x. And now from here, I can undo the second radical by squaring each side. So I'm going to go ahead and square each side. And when I do that, let me bring it up here. That's going to leave me with a 16 equals x. And that's it. There's nothing else really to solve here. So this one worked out really well. But now the last thing I have to do is I've got to plug this back in and check it. I have to make sure that x equals 16 actually works. So I plug the 16 in. Over here I have 16 minus 15, which is 1. Square root of 1 is 1, so I get a 1 over here. On the other side, I get 3 minus the square root of 16. Well, that's 3 minus 4, which is a negative 1. And so what happens here, I find out that 16 does not work, so it's an extraneous solution. And since there are no other solutions, it means there is no solution. So the answer here is no solution, okay? So I use the null set symbol. That's it. So make sure you plug these back in and check your answers. If I look at the next one, this time neither of these is isolated, so I have to isolate one of them. I'm always going to isolate the larger radical first, so I'm going to isolate the square root of x plus 36, so I'm going to subtract the 1 from each side. And it leaves me with this. So now I'm going to undo that larger radical now that it's isolated, so I'm going to square each side. When I do that, over here I'm left with an x plus 36. Over here, take it off to the side, multiply it out, so I have to square that binomial. And when I do, I'm going to get x plus 4 root x plus 4. And now I have to isolate the radical that's left, so I'm going to subtract the x and the 4 from each side. And it looks like this is going to work out similarly to the other one. This is going to give me a 32 equals 4 root x. We'll see if it gives me a valid solution this time. Divide each side by the 4. So when I do that, I get a, let's see, where was I? 8 equals the square root of x. And now I just have to square each side. When I do, I find out that x equals a 64. Last thing I have to do, of course, is plug it back in. So I'm going to plug this thing back in. When I plug it in on the first side, I have 64 plus 36, which is 100. Square root of that is 10, plus the 1 is an 11. So when I plug it back in, I get 11 on the first side. On the other side, I plug it in, I get the square root of 64, which is 8, plus 3 is an 11. So that one does indeed work. So I do have a valid solution here. Okay, but again, make sure you plug it in, check for extraneous solutions. All right? If I look at the next one, again, I want to isolate here. So to isolate this, once again, I want to isolate the larger radical symbol. So when I do that, I'm going to go ahead and I'm going to subtract the 2 root x from each side. And then I'm also going to divide by the negative just so I don't have anything else over here with this radical symbol. It's nice to have it all by itself, and actually it's going to work out really well because now on the other side it makes this guy a positive, which is just a little bit nicer to deal with. Okay, now I have that one radical isolated. I square each side. When I do that, over here I'm left with just the 2x plus 1. Over here I have to do that binomial times itself, so I have to FOIL. When I do FOIL, it's going to give me a 4x, a minus 4 root x, and a plus 1. Okay? And again, if you're having trouble following that, take it off to the side, multiply it out, see how it works. And now I'm going to get everything on the same side. I'm going to isolate that radical. So I'm going to subtract the 4x and the 1 from each side. So here I subtract the 4x and the 1. And that's going to leave me with a negative 2x equals a negative 4 root x. I'm going to divide by the negative 4. When I do that, let me bring it up here. That's going to give me a 1/2 x equals the square root of x. And now I'm going to go ahead and undo the second radical now that I have it by itself. So I square each side. That's going to give me a 1/4 x squared equals x. And now to solve this one, I'm going to subtract the x from each side. And I'm going to solve this one by factoring. And if that fraction is bothering you, we can just multiply each side by 4 and get rid of it. So that's going to give me an x squared minus 4x equals 0. Now solving by factoring here, I can factor an x out, which leaves me with an x minus 4. I set each factor equal to 0, so x equals 0, x minus 4 equals 0, and I solve each. This one's already solved. This one gives me an x equals 4, but now I got to plug them back in, make sure that they work. I plug the 0 in. That's going to give me a 0 minus, let's see, 2 times 0 is 0 plus 1 is 1. So that's going to be, let me write this out, that's going to be a 0 minus, that's going to be 1, which is a negative 1. So on that first side I get a negative 1. The second side I already have a positive 1, so the 0 doesn't work. So I can get rid of that one. I plug the 4 in. When I plug the 4 in, that's going to give me the square root of 4, which is 2. Times 2 is a 4, so this one gives me a 4. Minus here I've got 2 times 4, which is 8, plus 1 is 9, so it's going to be minus 3, which does indeed equal the 1, so that one checks out. So in this case I got one extraneous solution, one solution that works, so that's my only answer. Okay? If I look at this last one, this time I've got some cube roots here. So again, I want to isolate at least one of these. So I'm going to subtract this cube root from each side. And it just so happens that when I do that, I'm left with the cube root, this guy, equals a negative cube root of this. And so now, really, both of them are isolated, which works out really well. So now I'm just going to cube each side, raise each side to the third power. Just be careful when you do this. Over here, I'm left with a 12 minus 2x. Over here, keep in mind, this is like a negative 1 out front. So when I do this, negative 1 to the third power is negative 1. The cube and the cube root cancel out. So this piece becomes just an x plus 3, but I still have to multiply those two things. So really when it's all said and done, it becomes this. It becomes a negative x minus 3. And now I can finish solving this thing. I'm going to go ahead and add the 2x to each side. And now I'm going to go ahead and add the 3. And it looks like I find out that x equals a 15. The last thing I have to do, plug it back in, make sure it works. Over here, under the radical, that's going to give me a 12 minus 30, which is going to give me a negative 8. So I've got the cube root of negative 8 here. Over here, I get 15 plus the 3 is going to be the cube root of 18. And it doesn't matter what I do here. When I add these together, obviously this is a negative 2. This is not going to be a positive 2 no matter what I do here. That's going to be some decimal. So there's no way that that is going to equal 0, which means this is an extraneous solution. And since I have no other valid solutions, it's no solution. Okay?